Testing PRs in a Distributed PaaS Environment by Glenn Henriksen, who's a cloud mentor and developer at Justify. Glenn Henriksen is working as a mentor, evangelist, and developer in Stavanger, Norway, one of my favorite countries. Just before I let Glenn begin, a friendly reminder, please use Pine and send Glenn your questions and we will address them at the end of his presentation. Mars is your Glenn.
Thank you. So, hi, I'm Glenn. Hello, friends. Glad you can make it. I'm going to talk about how we improved and still are improving the process of testing our pull requests. I'll be talking about some of the decisions we made and some of the techniques we used to make things happen along the ride. So in order to make things make sense, we need a little bit of background first as to what do we actually do. We're a small startup. We provide some legal services online where you can go and you can fill out, you're guided through a wizard kind of thing where you fill out some information and you can create legal documents. Your will, your living will, your cohabitation contract, stuff like that. And we have multiple products. The customer journey is basically that they log on, they pick a product, they go through this guided information gathering, they submit their information, they pay us money, hopefully, and we create documents and they're reviewed by an actual lawyer, and then they go to signing and storage and they're sent to their homepage or my page. So that's the basic thing that we do. Now, behind the curtains, there's a few more things going on. We have a bunch of React front-end apps, which are one React app for each product. They're all deployed to Azure as an Azure website. We have some back-end services. We have an identity server, an API server for the front ends. We have a secure chat server. We have back office system. All of those are running as web sites on Azure, web apps, all running on a web plan. We have some jobs running as Azure functions, some timer jobs, some event-driven jobs. We have a couple of databases, and we have a couple of managed Azure services like Key Vault, like Event Grid, and App Insights. And all of this runs in one resource group per environment. And on top of all of this, we have Azure Active Directory. So that's the general layout of our infrastructure. Now, all the back-end services have separate GitHub repositories, or had. There's a non-trivial amount of shared code between them. They have some client libraries, some other utility libraries we like to use that are shared as NuGet packages. And we have the front end, there used to be separate repositories, but now they're gathered into one repository, one monorepo, where all of the shared components are directly available on disk, so we don't have to use NPM to share those components. We're using Azure DevOps for work item management to build and deploy pipelines, and we use Azure Artifacts for the package feeds. And we use GitHub to keep our code. We picked GitHub because it had a larger ecosystem for interacting with. And so we went for that while Azure DevOps interfaced well with GitHub at the time. We have infrastructure as code. So all of the code to deploy these things are defined as code. But they're separated in each repository. We have some Azure ARM templates, Azure Resource Manager templates, and we have some Pulumi scripts, which uses a nice TypeScript thing, while ARM templates just horrible JSON. And the process for a developer is make a code change. We pull the latest code in. We make a feature branch. We do our changes. We push it in that repository, and we make a pull request. Pull request is we review it, we learn from it, we share knowledge, and eventually it gets approved, where the code goes into the main branch. merges in, and it gets automatically deployed to a dev environment, to a test environment, and then it's waiting for a manual review before we go into production. So that's where we were. And to be fair, this was a pretty good system for us. It worked nicely. But as we grew and the code grew, we started getting into some issues. We started to get some friction. The main problem was this bit, where features would be queuing up. We would have one feature in test for testing, and then another feature would be ready and wanted to go into test for testing, but it couldn't go into test for testing. So maybe sometime we stuck it in after all, and some other times we just threw it out there. Oh, that's a button. So we would have features overriding other features that were being tested, and that was a huge issue for us. Another problem was that as the complexity grew and we started working more people, cross-functional together, we started getting cross-repository changes. So we would have changes in the front end combined with changes in the back end, and they were all in separate repos. And sometimes we'd have changes in multiple backends. So we'd have merge pull requests that wanted to be merged, maybe 2 or 3 or sometimes even more, that had to be merged in a certain order to make things work, which was very inconvenient. And you get these messages in the pull request, like, this has to be merged before or after this other one. So we needed to coordinate all this. This created friction for everyone involved. We got drift in the dev and test environment, where you would deploy backend API pull request and a front-end pull request to be tested. Then someone didn't know that, and they deployed or merged an API feature which didn't have the feature that was being tested. So that went in, and then suddenly you got conflicts where front-end expected something that the other one did. So we had to be very careful with what we were doing all the time. One-way database migrations, we'd put something in. It would migrate a database, add some fields, remove some fields, and then we wanted to pull back. So now, okay, this is not good enough yet. We need to do some changes. But then the database had jumped forward, so it was a lot of manual work to get that back. Various ways to deploy the apps. Our infrastructure as code was organized in different ways, ARM and Pulumi, but also on Azure DevOps. Some were in the classic pipelines, some were in the newer multi-stage pipelines. We could definitely do with more reuse because it was spread all over different repositories. And the cycle going from development to business and the production was getting slower. It was more and more over-the-wall kind of thing, where we would develop something and then merge it to main and then push it and dev and test, and then it was somebody else's problem. Then business needed to go in and figure things out. Feature wasn't done when you merged to main. There was still work left to do. And it was general friction, and we were starting to slow down. And also working with these pipelines on Azure DevOps can be a pain sometimes, where you get these kinds of commits after each other. Oh, that worked, that didn't work, that worked, that didn't work. Sometimes things just worked, and it was glorious. But unfortunately, it didn't always work that way. And I grew to learn to hate YAML. Anybody like YAML? One. Sicko. So we had some goals that we wanted to achieve. The ideal situation. What would be the ideal outcome here? Well, we wanted to unify and reuse our infrastructure as code. We didn't want it spread out all over, so we needed to do something with that. We wanted to be able to test multiple new features at the same time. We currently couldn't do that. We wanted to test pull requests continuously, not just after everything's done and the code review is done and we're sort of done developing it, then we actually tested it in an environment. We wanted to do that while we were working on the pull requests. Not merging until the main until the feature is done. So we don't really want half-finished stuff into the main branch that other people branch out of. We wanted a clean and freshly seeded database for end-to-end testing. The problem with our database is that they were also used for various testing purposes, demo, experimentation. So we couldn't rely on the dev and test databases to be in a certain state. So we wanted to have that for proper end-to-end testing. And we also want to develop, test, and even run pipelines locally on our machines. And we want a better cooperation with the other areas in the business so that they could come and work closer together and test features as we go along and as we work them and have a much shorter loop cycle with us. What we did not want was change the whole underlying platform of our infrastructure. For us, that meant not going to Kubernetes. We did not want that. There are multiple reasons, mainly that it doesn't solve all the problems we have. It would help us with some of the goals, but it would give us a whole bunch of other problems. Mainly, we don't have a lot of people that know Kubernetes, so we'd have to do a significant upskilling. And it would give us more stuff to handle. We're very happy with the platform as a service services in Azure, the websites, the serverless options for functions, where I just take the code and give it to Azure and they run it, and I'm happy. There's no sidecars to figure out. There's no different logging situations, no service message. We have a relatively simple setup, and we don't really need to complicate it. So we didn't want to go to Kubernetes. The benefits were far greater than the disadvantages, far smaller than the disadvantages for us, in our case. So what did we do? Well, we wanted to keep the existing infrastructure, so we looked at, okay, how can we deploy our changes to separate environments for each pull request instead of just pulling it to the regular dev and test system. Well, we had to expand our pull request triggers. So when you define a pipeline, you can define what events should it trigger on. And we had a pipeline that ran on pull requests, but it only did the build thing, so we'd get CI and run all the tests, or unit tests, small and some integration tests. But we wanted to actually deploy as well, so we could evolve with that. So we knew how to do that, we could just build on that, that's fine. So we had this infrastructure as code already, so not a huge problem. And there was the first problem. Changes going across repositories. How do we fix that? So in the beginning, we had this idea that we could make put special commands in the pull request, in the title, or tag something, then we could have some scripts that would pick this up and then deploy these services at the same time, and that one, and switch that one and use that one. And we figured that was way too much work. Don't lean on that table. So we opted for something simpler. We just went for one repo to rule them all. We went for a monorepo. We took all our repositories and moved them into one single repository. We used the add remote, then rename and merge technique. So we got all the file history with us, all the source history for all repos is in the monorepo. So that worked very nicely for us. So now this enables several things. First, cross-repo pull requests were a thing of the past. If there's a change that involves multiple apps, it's all in the same pull request. There's a lot less friction with packages because we stopped using NuGet packages. We just refer to the package on disk, so we have easier access. And when we update something, when a package is updated, we get compile errors for if it breaks another service, because that was another problem we had. We got runtime errors instead. And we could easily now deploy the whole system as a whole. So this enabled us to go to the next step, which is consolidating all our resource creation. Creating the web apps, creating the resource group, creating the app plan, all that stuff. We've been using ARM templates, massive JSON, totally unreadable. It's a write once language. And we'll be using Pulumi script, which we thought was really cool, but like half the time it wouldn't work on our machines. I think it turns out we have some weird setup in our subscription that makes it go barf. And that was friction we didn't need. And Pulumi didn't offer us anything really substantial in our use case. So we went for something called Bicep instead. Bicep is the evolution of ARM. It's a higher level language that compiles to ARM. It treats ARM like the assembly language. But it ticks our boxes. It is easy to write, easy to read, allows us to create templates, reusable modules, and has a great VS Code extension that make it a lot easier authoring those templates. So we could have gone with Pulumi, but we decided, okay, it's not worth it. We're satisfied with this. This is a Bicep template for creating a bunch of websites. It uses a loop here, underlined. So we have an array of site names, loop to that, call this other module that does a lot of work, and then create these. Here's some parameters that you need to send in. So it's a nice language. These loops theme features too as well, because we have multiple things that are pretty much the same. So we can start again. It also has a feature where we can take an existing ARM template and translate it to a Bicep template. So we now started getting all our app services deployed using Bicep templates instead. Relatively extensible way to add new services. And we can reuse and we can define, this is what a website looks like. This is what a backend website looks like. This is what a front-end website looks like. And we can just add new names to an array if we want to create more. And then we started hitting an area which we had neglected a little bit in our infrastructure as code, our guilty shame, the Azure AD resources. We're big on not using passwords and secrets, but using identities instead. So our apps run with what's called a managed system identity. So the app has an identity, has a username and password built into it that it can use to access resources. So Bicep handles that scenario just fine with the managed system identity, but for now, it cannot do the rest of the AD part. It cannot add other application registrations. It cannot add app roles. It cannot add users to app roles and all that stuff. That is coming sometime next year, first half, I think. But it doesn't really matter much. We can just use the AC client, which is the command line client for Azure, and just script those things. So that worked out pretty neatly. As an example for what we use Azure AD for is to add the managed system identity for the web app to the SQL server for authentication, so we don't have to have a connection string with a password in it, because that is not particularly safe. So here's an example of the script to create the database users for the different web apps. Interesting thing here, we're using AC account get access token to get a token for the identity that is running the deployment script. And we want this token to be for the database. And then we can use the invoke SQL command, a PowerShell command, and attach that token to the command. So as long as the user identity I'm running my script as has permissions to the database, I can ask for a token, get it, and then use that token to access the database. Which means my script don't necessarily have to have any secrets or passwords on the environment variables and stuff like that. We'll get back to a little bit of that afterwards as well. Speaking of databases, what do we do with all our managed services which we don't deploy? We don't necessarily put our code on those. So deployment is more than just our apps. Do we share them between the different environments? Do we put them in the different environments? And we decided to put them in with a deployment. Each environment gets a free, fresh set of managed services, gets its own event grid, gets its own app insights, gets its own databases. The thing with the cloud is that it doesn't really cost you to create a resource and keep it. It just costs you when you use it. So there's not really any cost to us just to create multiple resources. So we just made more of those. Now we have everything in our resources set in the repository. It's full of infrastructure, and we can start deploying our code. We do this just using regular AC CLI commands, like this: web app deployment, source, config zip. We publish our app, deploy it. We use a relatively strict naming policy that is very convention-based, so all the resource name can be derived using those conventions. So it makes it convenient to just code in your script what you're getting, as long as you have a little bit of the information. The rest can be just derived from wherever you are. We can also use the AC deployment group command to get output from the resource deployment, to get names and addresses that may or may not be static or not easily derived. So now we have our databases, but where there's no data in it. So using a testing environment without data is pretty boring, so we used this chance to do something we wanted to do for a long time, which was to have some structured way of seeding a fresh database. We want this both for our local environment, developer environments, because it's sometimes nice just to have a fresh start. But we want a fresh database with some data in it for every new PR environment. And what we did, we made just small console apps accompanying the application, the backend apps that had the database, that would use the same objects and the same EF core DB contexts and just seed some data. We've run the migrations as SQL files before, but we didn't want to run the data migration as SQL files because when we use the actual objects, we get, again, compile time errors if we change something and forget to change the seeding part. We also use Bogus to generate some data. Some data is static, but some we generate. Bogus is a nifty little thing that will give you just set a rule for something random. So here's a bunch for making fake messages in our chat backend. The content should just be a lorem sentence. The written by should be a random pick of a list of people. The written at time should be a datetime offset, sometime in the past. We don't care what. And then we just generate 5 of those. And I've gone 500 here, it doesn't matter. Bogus just generates data. It's very useful for generating huge sets of test data. And one of the advantages is you can set it to a fixed seed number and will generate the same data every time. So you can rely on it in your tests. So Bogus is very nice. And while we're on the stuff that might be bogus, DNS, it's always DNS. We wanted to use our own domain for the services. Azure gives us their Azure domains, but we didn't want to use those for our environments because, I don't know, we're vain and narcissistic, but we wanted to it. So we do this using Azure DNS, which Bicep takes great care of. Here's part of the code for setting up a delegation. We have one root zone that is long-lived, and then we use Bicep to add a new DNS zone for that in particular environment, and then we delegate from the root zone down to the environment zone, the PR zone. So that gives us addresses like app.pr123.justify.no, for instance. So it becomes easy to remember. It's easy for someone to just type it in and, oh, I'm on number 124 or 245, whatever, and they have a convention they can follow. So now we have our services deployed on infrastructure existing. It has data and has a domain name we can access. Now it's time to start giving that information back. So what we can do is we use the GitHub Script action to post comments back to the PR with the URL of the fresh deployment. So when we post something, when we put up a PR, the pipeline, the workflow, the GitHub workflow runs. It does its deployment, all that stuff, and then we have an action on GitHub Actions that will post a message back to the actual, as a comment on the actual pull request, and saying that, hey, you'll find it here. So then it's convenient for whoever is working on, just click that link and go off. GitHub Script, if you're working with GitHub Actions, I highly recommend this. You can do amazing little stuff with it and react to a bunch of events and run JavaScript against the GitHub web services. So it's very, very convenient. It looks sort of like this. This is the part for posting a PR comment. So it's GitHub issues, create comment. GitHub is weird because a pull request is actually a special issue. So it has the same API and everything. So script, create comment, issue number, get some data from the context, the owner of the repo, the body, just the text. And the URL has been put into an environment variable by the deployment further up. We haven't yet, but we are going to expand our workflow to post messages to our Teams site, channels as well, making it easier for the rest of the company to pick up on changes and where things are at, because not all of them spend their life in GitHub. So there's a Teams action available on the marketplace, and we're going to use that along with this little nugget that is able to get some extra information out of the pull request and not just the thing that is in the context. So we might want to pull out the pull request title, for instance. So some of you may notice that I've been talking about GitHub Actions for a while, and in the beginning I said we were using Azure DevOps for build and deploy pipelines. That is absolutely correct. We were, and now we're moving over to GitHub Actions, or have moved over for GitHub Actions, but we're also moving over to GitHub for other things as well. We decided to use this opportunity to migrate our workflows or pipelines to GitHub Actions. They are similar to Azure DevOps pipelines if you squint. They're not exactly the same, but they are a lot more flexible, and there's a bigger ecosystem around GitHub than it is around Azure DevOps, so we can take more advantage of that. And they offer a better integration with the pull request issue, like we saw with GitHub Script. And it is also our prediction that GitHub will be the place where the innovation and new work primarily will happen. So we're actively migrating off Azure DevOps with all our stuff. It's not dead. It's going to be around for years and years, but that's not the place where the big things are going to happen. And you can also see who people moving off the teams to GitHub. I mentioned a little bit about security and passwords and secrets. So running our workflows in GitHub while deploying to Azure leads to a little security challenge. How can we get our GitHub workflow to have permissions and authenticate to the Azure environment in a safe and secure way without having to store or pull out some credentials and store those in GitHub as secrets, not in source control, but as GitHub secrets. We don't want to do that. For one thing, it's a security risk with having credentials flying around. The other thing, these credentials that you create usually have a lifetime. They expire, and it's always inconvenient when they do. So, but luckily for us, we were ready to do that. It's like, okay, we're going to have to suck it up and do it. But luckily for us, Microsoft and GitHub released a solution where GitHub repo can have a federated identity into Azure. So what you can set up what's called a service principal with Azure, which is a username, an account for a non-human. And you can allow GitHub on that particular organization and that particular repository, when doing pull requests, for instance, to be able to ask Azure, can I please have a token for that service principal? And Azure will give it that token, provided all the other things match up. Because GitHub and Azure have now exchanged a bunch of keys. So Azure can trust the request coming from GitHub, saying, yes, this is actually that organization and that repository asking for an access token, which GitHub, a workflow, can then use to log into Azure and get access to all the resources. And I can use the service principal I have created in Azure to regulate what they can do where. So I can say, okay, you're allowed to deploy to this subscription, but not that subscription. You're allowed to create things here, but not here, for instance. So this enables us to securely give our repository access to Azure and only the relevant parts. And I don't have to store long-lived credentials somewhere in GitHub that, again, will always expire at an inconvenient time. So now we have this nice, fresh environment, freshly seeded database, perfect time to run some end-to-end tests. I'll admit that we haven't been big on end-to-end tests since we didn't really have a good environment to run it in that had a stable database. So we're just getting started there. We want to keep them few and not too complicated, but we want to test the happy paths. All the edge cases, we'll do that in snapshot testing, unit testing, integration testing further down. But the end-to-end test, we don't want to break those for every minor change, but want to keep the flow going. One of the things we had been doing was, because we create documents, PDFs, basically, that are sometimes signed physically and sometimes they're signed digitally, but it's ended up as a PDF. And it's important for us to make sure that those don't change unexpectedly when people are doing changes somewhere else. So we had a mechanism to upload all our PDFs to a service called Percy. Anyone ever use Percy? Yeah, one. Same guy that likes YAML. Percy is a service that will let you do visual comparison of snapshot images, but it will do it for you first. So we'll look at a bunch of images compared to what they got the last time, and it will highlight whatever differences there are. It will look something like this, and you can see, okay, here's some differences. And then you can either approve this, saying, okay, that's fine, that's perfect, move on. Or you can say, hey, this needs to be changed. And Percy offers a very smooth and fast interface for doing this, and it integrates very well with GitHub pull requests. It will come up as one of the checks, the pull request, saying, hey, here's some things that needs approval. Click the link, you take it to Percy, you can, that's fine. Approve that. Oh, this happened. Oh, you don't want that. We need some changes here. So since we already had this stuff going, it was relatively simple for us to start implementing that with our end-to-end testing as well, where we're using Playwright to run the tests, to hit the endpoint, put in data, log on, go through a fixed set of actions, and then take snapshots of those websites as it goes along, upload those to Percy, and then we get a whole visual testing of the site as well, making sure that we don't unexpectedly break something. So we're in the process of implementing this, and it is working very well so far, at least. So now we have all these moving parts, and we need to put them together. We have two classes of things to do. We have some things that are related to the creation of resources, deployment of code, running of tests, all that stuff. and another set of things which are related to workflow management. Posting comments in the PR, responding to this event, sending a message to teams, such like that. So we decided to split it out a bit and say, okay, the things that has to do with workflow management, they will go in as tasks in GitHub Actions. GitHub Actions has this concept of tasks, where you can specify a task, which can be a GitHub script, like I showed you. It can be a whole Docker container with an application of your choice running on it. You can make your own custom actions or tasks. But for the other parts, we decided to stick with just calling plain PowerShell scripts or CLI commands to make it easier to run those locally on our developer boxes. But these things also need a little bit of organization. So we're using something called Bullseye in combination with something called simple exec to get a nice dependency graph with Bullseye of target and its dependencies. So we can organize these commands. So we have a target here. We have a target build, and if you run the target build, you will run .NET build. And then there's another target called publish, and that depends on a target called clean. So we'll automatically run that first, and then it will run .NET publish. This is a simple example. But enables us to split the different things we're doing into different targets and make a dependency graph of we want to run this thing, but that means we have to run this thing and this thing and this thing first. So we basically can split things up in various functions, and it's a very convenient way of organizing our code, our build code. We looked at other build tools like Nuke and Cake. And for us, in our use case, we found this to be sufficient. The other ones had more features that we didn't really need, so they just added a bunch of noise, actually. So these were our goals. So to recap, how are we doing? Well, we now have unified our infrastructure as code. We're able to reuse parts and keep it nice and dry, so we checked that one. We can now test multiple features at the same time, so we're good to go with that. We can deploy multiple PR environments in parallel. We can have as many as we want. There's no limit to it. We can deploy these PRs as we go along with the pull request, so that we can keep seeing, okay, how does it look now? How does it look now? How does it look now? If we're working on a feature that might take a more substantial change, we can constantly have an updated environment with how does this look, which is nice, especially when you have asynchronous communication with events going back and forth and subscriptions being set up as well. All of that stuff is scripted, so that works very well. We don't merge to main until the feature is done. So main is always fresh. There's never any half-baked work in main, so we're happy with that. We can get a clean and nice database, do end-to-end testing. And now we can also develop our pipelines locally by using Bullseye and simple exec to run these tasks. It doesn't matter if we run them on a CI server or if we run them locally, they work the same. And we now have better cooperation with the other areas of the business where they are more informed. They can be tighter on the development. And they can stop things and call out things and test things as we go along instead of waiting for us to build something and then they get to look at it. So that enables better ways of working together. We're not done. This is a continuous effort. There's much more to do. I mentioned we want to get into teams to get more information in the face of more people in the company, not just the ones that hang out in the pull request. We want to get more what's called chat ops, where we can do actions in teams by chatting to a bot or having the pull request post cards with actions on it in teams. So we have an idea that you can, when it posts to teams that pull request so-and-so is now live, you can have a button saying approve for production, and you just approve that in Teams if it's good to go, and you're off. As our end-to-end test gets better, we have still some work to do there. We want to start moving to continuous deployment to production. So it's more of a courtesy call that you can follow along as you go, but we want to skip the manual part there as well. And we want to introduce more services to make our applications scale better or work better, which is now easier since we can just add these services in the common infrastructure as code part. So there's lots of stuff to do there. Any questions?
Just run with the microphone.
Hi.
Hi.
Yeah, thank you for a great presentation. Really interesting.
Oh,
so, one question from my side. So, how were you impacted with the build time of the monorepo after you switched to this way of building stuff, right?
Not that. So, how are we affected with the build time? Not that much, because we have run builds and tests first, and we specify which task we want to run depending on what paths have changed. So in the pipeline, we can say this thing should trigger, but it should only trigger if this path has changes.
So you're not rebuilding the entire stuff, right? Only the affected projects?
Not at first.
Oh.
We do it afterwards for the deployment part. But those are two separate things. So we have the CI that runs the unit tests and runs the builds and make sure that, oh, well, you didn't check in bad stuff. That runs first and gives a green check on the pull request, and then we do a deployment after the fact.
Okay, so in total, so how much time does it take to pre-build the stuff, make sure that nothing bad happens, and then rebuild the entire stuff with building the Docker images before we can proceed to the deployment? So on average, how much time is that?
I'd say the build is, a lot of it is can be done in parallel, so we do that. The front end is the one that takes the longest. Some of the front ends do 5-7 minutes to build. But we have some tricks that we have employed in some of the front ends that gets it down to 2-3 minutes for the build. The deployment is reasonably fast. It'll take a couple of minutes to deploy. But in the PR environments, it's not, the whole infrastructure might take, I don't know, 4 or 5 minutes to set up, in our case, most of the time. Sometimes it will take longer. And then for production and for the test environment, when we go there, it takes sometimes even longer, because then we deploy to staging slots and we swap slots. And that will sometimes hang for like 15 minutes. But usually we'll have, on average, between, I don't know, 4 to 8 minutes building everything in parallel. And then we'll have about the same deploying everything. So we take some of the jobs and parallelize the jobs running on multiple hosted agents. So we can build the front ends here, and we can build this back end here and this back end here. So they're all running in parallel, so we don't have to build one after one after one after one after one. So that makes it easier. So I don't know, it's from you push till you get it into a PR environment, between 10-15 minutes thereabouts on a normal day. Sometimes it's 20. It's the cloud, so it varies.
Any further questions? Thank you very much. Applause for Glenn.
Thank you.